Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice for how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today. The time t that a manufacturing system is out of operation has cumulative distribution function f of t equal to 1 minus 2 over t, the whole quantity taken to the power 2, so squared, for t greater than 2 and 0 otherwise. The resulting cost of the to the company is y equals t squared. Determine the density function of y for y greater than 4. So you know that this is a transformation of a random variable, and one way to approach it is to just rework the cumulative distribution function from the information, and the other one is to memorize the formula for the density. If we work with the cumulative distribution function, f sub y of y is the property that y is less than or equal to y, which is the same as the property of t squared being less than or equal to y. And in general, this is equivalent to the property that absolute value of t is less than or equal to y, but t is positive in this case, so this is the same as property that t is less than or equal to square root of y, which is f sub t, the cumulative distribution function of t, applied to square root of y. So if we plug in that square root of y into the formula for the cumulative distribution function of t, then we get 1 minus 4 over y for y greater than 4. Because y is equal to t squared and t has values from 2 to infinity, then y, the square of it, has values from 4 to infinity. We differentiate this to obtain the density function, and that becomes f sub y of y equal to 4 times y to the negative 2, and this is answer A. Or you can find the density of t. F sub t of t is a derivative of the cumulative distribution function, and that's equal to 8t to the negative 3. And consider the transformation that we have, y equals t squared. The inverse of the transformation is t equals square root of y, because the values are only positive. So for positive t and y, square root of y is the inverse of y equals t squared. So t equals square root of y is the inverse of y equals t squared, because we only work with positive values. And the quadratic function t squared is 1-to-1 for t greater than or equal to 0. In fact, t is greater than or equal to 2, greater than 2 actually. And the derivative of the inverse function is, well, what's the derivative of square root? It's 1 over 2 square roots. And therefore, f sub y of y is f sub t applied to t that corresponds to y times the absolute value of a derivative of the inverse of the transformation. So the absolute value of dt over dy. You need to memorize this formula for the test. It's very serious, very important. So we plug in what is the value of t that corresponds to y. It's the square root of y. Okay, so that's f sub t of square root of y. And then what is the derivative of square root of y? It's 1 over 2 square roots of y. So f sub t applied to square root of y. That's f sub t of t is 8t to the negative 3. So we plug in square root of y, and we get 8y to the power negative 3 over 2 times 1 over 2 square roots of y. And if you cancel it out, you will get 4 over y squared, just as before. And of course, again, t is greater than 2, then y is greater than 4, because y is equal to t squared. So, answer A. Please remember this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.